Sawa, ukiangalia u ilikuwa ni 30 meter per second, utatoa final velocity was 0 meter per second, utagawanya kwa 10 meter per second square. Kwa time to reach the maximum 8 itakuwa ni 30, kwa sababu mita na mita zitapungua, kwa hapa tutabaki na second, tukiganya kwa ngapi? Kwa 10. Kwa time to reach the maximum 8 will be equal to 3 second. Kwa uta conclude kwamba time to reach the maximum 8 was 3 second. So time to reach the maximum 8 was 3 second. That is how you can calculate the time reached, or the time when the body reaches the maximum 8. So now let's do part C of the question. Part C of our question. Part C of our question, we were required to find time taken for reaching the ground again. Time taken for reach ground again. Ambapo ukiangalia kwenye mchoro tulikuwa tumeandika ni T3. Kwa hiyo tunaenda kutafuta time the stone uses to reach the ground again. Tutafanyaje? Tunajua kwamba tuna data zifuatazo. Tuna initial velocity ambayo u sawasawa na 0 meter per second, lakini tuna final velocity ambayo sawasawa na 30 meter per second, lakini pia tuna time from h ambayo ni maximum 8 and ground. Hiyo hatuna, lakini pia tumepewa acceleration ambao a nao sawasawa na g ambao sawasawa na 10 meter per second square. Kwani imekuja kuwa sawasawa wakati tunajua body will be thrown vertically upward. Now it is positive because ile stone imesha reach maximum 8 na now it undergo a free falling motion, and when it undergo the free falling motion data zake zitabadilika, au value ya acceleration due to gravity itakuwa ni positive. Kwa hiyo tukiwa tunatafuta hiyo time tutasema from Newton first equation of motion ambayo inasema v ni sawasawa na u plus g t. So now let's find the value of t. So it will be, if you make gt the subject, it will be v minus u, then divide by g, divide by g. So now to find the t, it will be to find the value of t, it will be equal to v minus u over g. As we know, the value of v was 30 meter per second minus 0 meter per second, then you divide by 10 meter per second square. So t will be equal to 3 seconds. That is the time from the maximum 8 up to the ground. But to find the total time the stone will take when it's thrown upward and when it become, or when it return to the ground, we must take the summation of the time the stone used to be at the maximum 8 and from the maximum 8 to the ground. So t3, which is the time to reach the ground again, it becomes t plus t2. So t3 will be t tumepata ni 3 second, tutajumlisha t2 tulikuwa tumepata ni 3 second. Kwa t3 sawasawa na 6 second. That will be the time used by the stone to reach the ground again. So, but alternatively, we can do this by taking that alternatively. We can do it by saying that time to reach the ground again is equal to 2 time to reach the maximum 8, where time to reach the maximum 8 was 2, was 3 seconds. So 2 times 3, you get t3 is equal to 6 seconds. That is how you can find the time to reach the ground again by the stone. So now let's finish the part D of the question. We were required to find velocity reached halfway to the maximum 8. Let's call it VH is equal to how much? So we know that we already been given when the stone is thrown vertical upward, and we already got the value of H max. So H max from, we are being given the value of H is equal to 45 meter. So H over 2 will be equal to 8 we are being required, which is equal to 45 meter divided by 2. So when you take 45 and then you divide by 2, you will get equal to H is equal to 2.5 meter. But we are not required to find the value of 8, but we are required to find the value of velocity when the object or the stone reaches the halfway of the maximum 8. So now let's find the value of velocity. Because the body is still on opposing the acceleration due to gravity, so A is equal to negative g, which is equal to negative 10 meter per second square. Then we say that from VH square it will be equal to U square minus 2GH. Now we are going to find the value of VH. So VH will be equal to VH square will be equal to 30 meter per second, but bracket square minus 2 times G is equal to 10 meter per second square times 2 to 0.5 meter. So if you times, you will get VH square is equal to, hapo utapata ni 900 meter. After calculating the value of velocity, which is half of the maximum 8, now we have a task to work on. The question states that an object is thrown straight up with an initial velocity of 50 meter per second. Then part A, how long will take to reach its maximum 8? How long will that object take to reach its maximum 8? But part B, to what 8 will it raise? So in that part you will find the maximum 8, but also what will be its velocity when it returns to its starting point. When the body will return to its starting point, what will be the velocity? But the last part is how long will be in the air. How long will an object be in the air? And by saying so, this makes the end of our topic and the end of our lesson today. Welcome on the coming lesson. Stay on watching Educare TV. Thank you.
Purchase your tracks today.